Assalamu alaikum. So, hello and good evening, everyone. I hope you're all doing well and having nice holidays for those who are in holidays, and in nice working conditions, of course, for those who still working till now. So, I'm happy and honored to meet you all today and again in this MENA Digital Days event series because we've already met in the last Cloud Week where we talked about Kubernetes. So this time it will be a little bit different. We are not gonna manage containers and workloads, but we'll try to understand and choose the best database that fits more our application. Um, so before we start, I invite you to fill the survey form so you can have your attendance certificates and also join the weekly challenge so you may win a gift of goodies or a Google Home Mini if you go further in the challenges. So like you've seen before, I am Afaf KELAI from Algeria, and we'll discover together the different storage data services in Google Cloud Platform. Like we know all, every application needs to store data, whether it's business data, media to be streamed, or sensor data from devices. And from an application-centered perspective, the technology store and retrieves the data, whether it's a database or an object store, is less important than whether that service supports the application's requirements for efficiently storing and retrieving data. So the question is, are we using the right service for our application? Google Cloud provides a full range of services to satisfy all of your storage needs. Cloud Storage, Cloud SQL, Cloud Spanner, Cloud Firestore, and Cloud Bigtable. Let me start by giving you a high-level overview of these different services. So this table shows the storage and database services and highlights the storage service type, relational, non-relational, objects, and data warehouse. Like you can see, BigQuery is also listed here because it sits on the edge between data storage and data processing. You can store data in BigQuery, but the intended use for BigQuery is big data analysis and interactive querying, but we will not be talking about it today. So like we can see here, for object storing, we have cloud storage. It's good for binary or object data, such as images, media, serving, and backups. For relational, we have two services, the Cloud SQL and the Cloud Spanner. Cloud SQL, which is good for web frameworks such as CMS and e-commerce. For non-relational, we have the Cloud Firestore, which is good for our mobile and web applications, and it's really related to Firebase as well. We will see also Bigtable, and that's it. For BigQuery, we're not gonna. But before we go further in our way to discover all those products, let's explore this decision tree, which will to help us to identify the solution that best fits our application. Let's walk through this together. So, the first question you should ask yourself before going further with those services and products is, your data structured? If it's not, or maybe if it is, so if your data is not structured, you can use cloud storage. If your data is structured, then you should ask the question, does your workloads focus on analytics? If it does, you will want to choose Cloud Bigtable or BigQuery, depending on your latency and update needs. Other ways, check whether your data is relational. If it's not relational, choose Cloud Firestore. So if it's relational, you will want to choose Cloud SQL, like we've seen already on the table before, on the slide before. So we gotta choose Cloud SQL or Cloud Spanner for relational database, depending on your needs for horizontal scalability or vertical scalability. And we will see those two terms, horizontal and vertical scalability, later when we talk about Cloud Spanner. So depending on your application, you might use one or several of these services to get the job done. Let's start with cloud storage. So Google Cloud Storage is an object storage service offered by Google Cloud. It provides some very interesting out-of-the-box features such as objects, versioning on fine-grained permissions that can make development easy and help reduce operational overheads. Google Cloud Storage serves as the foundation of several different services. So cloud storage is used for a range of scenarios like we can see on the slides here, including serving website content, storing data for archival and disaster recovery, or distributing large data objects to users via a direct download. Cloud storage has 4 storage classes: regional, multi-regional, nearline, and codeline. Let's talk about regional storage. So regional storage enables you to store data at a low cost with the trade-off data being stored in a specific regional location instead of having redundancy distributed over a large geographic area. Personally, I recommend you using a regional storage when storing frequently accessed data in the same region as your compute engine instance. This provides you with better performance for data-intensive computation. So, while multi-regional storage, on the other hand, is a geo-redundant, which means cloud storage stores your data redundantly in at least 2 geographic locations separated by at least 100 miles within the multi-region location of the bucket. We will see what is a bucket later in this session. Multi-regional storage can be replaced only in multi-regional locations such as the United States, the European Union, or Asia. So multi-regional storage is appropriate for storing data that's frequently accessed, such as serving website content, interactive workloads, or data supporting mobile and gaming applications. We have now the nearline and the codeline classes. The nearline storage is a low-cost, highly durable storage service for storing infrequently accessed data. So we have regional and multi-regional for frequently accessed data, while nearline and codeline for infrequently accessed data. The storage class is a good choice when you plan to read or modify your data less than once a month because the storage cost is low. It's also recommended using nearline storage for backups and serving long-tail multimedia contents. Codeline storage is a very low-cost, highly durable storage service for data archival, online backup, and disaster recovery. So codeline storage is the best choice. So codeline storage is the best choice for data that you plan to access at most once a year due to its lower storage cost but higher retrieval cost. Let's focus on durability and availability. Like you can see here on the table, we have here for all the classes, regional, multi-regional, nearline, and codeline, it has 11 lines of durability, which means that you won't lose data. You may not be able to access the data, which is like going to your bank and saying my money is there, but I can't have it because the bank is closed. I don't have access to it, which is the availability that differs between the storage classes. Cloud storage is broken down into a couple of different items. First of all, there are buckets. which are required to have a globally unique name and cannot be nested. So when you want to use cloud storage and you want to create it on the console, the first thing you're gonna do is to create a bucket. You will give it a name, a unique name. This bucket cannot be nested. The data that you put into these buckets are objects that inherit the storage class of the packet. And those objects can be text files, doc files, video files, and so on. There is no minimum size to those objects, and you can scale this as much as you want, as long as your quota allows it. To access the data, you can use the gsutil command or either the JSON or XML APIs. So I think we are here at the end to explain cloud storage. Let's explore the decision tree to help you find the appropriate storage class in cloud storage. If you will read your data less than once a year, you should consider using cold line storage. If you will read your data less than once a month, you should consider using nearline storage. And if you'll be doing reads and writes more often than that, of course, you should consider choosing multi-regional or regional, depending on your local needs. I hope that was clear. Let's move now to the Cloud SQL. Cloud SQL is a fully managed service of either MySQL or PostgreSQL database. Cloud SQL delivers high performance and scalability with up to 13 terabytes of storage capacity. Also, 416 gigabytes of RAM per instance. You can easily scale up to 64 processor cores and scale out with replicas, and can use Cloud SQL with either MySQL 5.6 or 5.7 or PostgreSQL 9.6 or 11.9. Let's focus on some other services provided by Cloud SQL. There is a replica service that can replicate data between multiple zones as shown on the right here. This is useful for automatic failover if an outage occurs. Cloud SQL also provides automated and on-demand backups with point-in-time recovery. You can import and export database using MySQL dump or import and export CSV files. Cloud SQL can also scale up, which does require a machine restart or scale out using read replica. Now let's explore the decision tree to help us find the right data storage service with full relational capacity. If you need more than 30 terabytes of storage space, okay, I hope you can hear me now. I will try to continue. Sorry, the connection here is not stable. So, anyways, so like we were saying, if you're using more than 13 terabytes of storage space or over 4,000 concurrent connections to your database, or if you want your application design to be responsible for scaling availability and location management when scaling up globally, then consider using Cloud Spanner. If you have no concern with these constraints, ask yourself whether you have specific OS requirements, custom database configuration requirements, or special backup requirements. If you do, consider hosting your own database on a virtual machine using Compute Engine. Otherwise, I strongly recommend using Cloud SQL as a fully managed service for your relational database. So, till now, we've explored two services: cloud storage for non-structured data, and we have cloud storage for non-structured data, and Cloud SQL for structured relational data. Now, we will discover other three services: Cloud Spanner, Firestore, and cloud database. Let's start with Cloud Spanner. Talking about scalability, Cloud Spanner is a very interesting database system. According to its documentation, it's the first scalable enterprise-grade, globally distributed and strongly consistent database. It's how a combination of the characteristic of a vertical scalability that's associated with the relational database systems and horizontal scalability, which is associated with non-relational database system. The concept of horizontal and vertical scalability is quite basic. So, when an instance is said to be vertically scalable, it means that resources can be added to increase or decrease its capacity. Horizontal capacity, on the other hand, means other instances can be created if there be need for them. So horizontal scalability means that you scale by adding more machines into your pool of resources, whereas vertical scaling means that you scale by adding more power to an existing machine, such as CPU and RAM. Now, let's compare Cloud Spanner with both relational and non-relational database. Like a relational database, Cloud Spanner has schema, SQL, and stroke consistency. Also, like a non-relational database, Cloud Spanner offers high availability, horizontal scalability, and configurable replication. As mentioned, Cloud Spanner offers the best of the relational and non-relational worlds. These features allow for mission-critical use cases such as building consistent systems for transactions and inventory management in the financial services and retail industries. Again, let's understand the circumstances when you would use Cloud Spanner. Let's look at the decision tree. If you have outgrown any relational database on turning your database for throughput, high performance, needs transactional consistency database, or turning your database for needs transactional consistency, global data, and strong consistency for just want to consolidate your database. Consider using Cloud Spanner. So if you don't need any of these, nor full relational capacities, consider NoSQL service, such as Cloud Firestore. Here, we're going to talk a little bit about the new announcement of Google during this next. So Google announced a slew of new features for Cloud Spanner. The most important new feature is the managed backup restore, which is new, generally available, and provides protection against user or application errors that results in logical data corruption. Google also added new features to add more reliability, flexibility, and ease of use when developing application with Spanner, like foreign case, C++ client libraries, and query optimizer versioning. So far, we have considered two databases for structured data, which are mostly based on server network. Cloud Firestore is non-structured document database, so it's a NoSQL document database that runs on a serverless platform. It's a flexible, scalable database for mobile web and server development from Firebase and Google Cloud Platform. It was formerly called, and still called, of course, Cloud Data Store, but with its recent integration with the security features of Firebase, it becomes known as Cloud Firestore. So if you're looking for a highly scalable NoSQL database for your application, Cloud Firestore is for you. Cloud Firestore is fast, fully managed, serverless, cloud native NoSQL document database that simplifies storing, syncing, and querying data for your mobile, web, and IoT apps at a global scale. Its client libraries provides live synchronization and offline support, and it securely features an integration with Firebase and GCP accelerates building for a seamless app. Cloud Firestore also supports async transactions. So if any of the operation in the transaction fail and cannot be retrieved, the whole transaction will fail. To summarize, if your Sigma might change and you need an adaptable database, you need to scale to 0, or you want low maintenance overhead scaling up to terabytes, consider using Cloud Firestore. So that's it for the Cloud Firestore. The last one and the last service we're going to talk about today during this session is Cloud Bigtable. Cloud Bigtable belongs to the NoSQL database class. So it's what you consider when your projects involve single-K large-scale data and you want low latency as well as good data persistence throughput. It's built for big data and its capacity is in petabytes. So if your application is big and important and you need a database that is fast, simple to maintain, and scale gigabytes to petabytes with no downtime, Cloud Bigtable is a solution. Cloud Bigtable is mostly used by Google in its analytics, search, maps, and Google Earth services. So Cloud Bigtable is a great choice for both operational and analytical applications, including IoT, user analytics, and financial data analytics, because it supports high read and write throughput at a low latency. It's also a great storage engine for machine learning applications. Cloud Bigtables integrates easily with popular big data tools like Hadoop and Cloud Data. Now, to quickly conclude, so if you need to store more than 1 terabyte of structured data, have a very high volume of writes, need read-write latency of less than 10 milliseconds, along with strong consistency, or need a strong service that is compatible with the H-based API, consider using Cloud Bigtable. So till now, I think we've seen the most services that offer GCP for developers, data scientists, or anyone who want, or maybe also enterprises who wants to store data or choose the right service. I hope that was helpful for you all, and I think that is what we have for today. I re-invite you to fill the survey form and to join the weekly challenge by completing 6 quests on Quick Labs. And if you want to win a Google goodies, and 12 quests if you want to win a Google How Many. Thank you for your attention. From me, Afaf, and from the whole JDG MENA team, have a nice day. Thank you.